This is the lesson for 12-1. What we're going to be looking at in this chapter are polynomials, all right? You're going to be doing all sorts of things with exponents and involving polynomials. What you're doing today is you're going to look at different types of polynomials, and you're also going to be adding and subtracting polynomials. First of all, what the heck is a polynomial? Well, a polynomial is an expression where terms are added or subtracted. This right here, this x cubed, remember cubed is the third power, plus 8x squared minus 10x plus 5, that is an example of a polynomial. You have to know what a degree of a polynomial is. The degree of the polynomial is your highest exponent in your polynomial. So the degree of this polynomial would be 3, because 3 is the highest exponent that we have here. Now, you have to keep in mind that whenever you have a letter all by itself like this, where you just have an x, that is really x to the first power. When you have just a plain number, that's really 5 to the 0 power, all right? So the degree of the polynomial is your highest exponent. In this case, it would be the 3. A term is a power that is being added or subtracted. There are really 4 different terms here. This x cubed is a term. It's really 4 different items that we have here. We have an 8x squared. That is another term. We have a negative 10x. That is another term. And we have a 5, which is our 4th term. So there's really 4 different terms here that we are adding and subtracting together to form our polynomial. But each one of these individually is called a term. The coefficient. The coefficient is the number that's in front of the power. So it's the number that's in front of the x. What number is really in front of this x? There's really a 1 in front of the x cubed. There's really an 8 in front of the x squared. There's really a negative 10 in front of the x. And then you have the 5. All of those are coefficients. The degree of the term. The degree of the term is the exponent of the term. So the degree of the polynomial altogether was 3. That was our highest exponent. But each of these individual terms has a degree as well. This is degree 3 because it's the third power. This is degree 2 because it's the second power. This is degree 1 because it's the first power. This is degree 0 because it's to the 0 power. A monomial is a type of polynomial that only has one term. For example, if we just had a term that said 4x squared, there's only one term there, that's a monomial. A binomial, bi means 2, mono means 1, bi means 2. It's 2 terms that are being added or subtracted together. So you might have something like 2x minus 5. There's 2 terms there. A trinomial is a polynomial that has 3 terms. Tri means 3, mono means 1, bi means 2, tri means 3. You might have something like 5x squared minus 4x plus 1. There's 3 separate terms there. So monomial, there's 1 term. Binomial, there's 2 terms. Trinomial, there's 3 terms. Standard form. Standard form becomes very, very important throughout the whole chapter. You're always going to put your final answers in standard form. All that standard form is that the terms are put in order from the largest exponent to the smallest exponent. This example up above is in standard form. Notice our biggest exponent comes first, then our next biggest, then our next biggest, then our next biggest. That's in standard form. If we had something like x to the 5th, that would come before like x to x squared, for example. That would be in standard form because the 5 comes before the 2, all right? So those are all vocabulary words that you need to know. We'll be using these throughout the whole entire chapter. Taking a look at individual polynomials and identifying some parts and pieces on them. So what is the degree if we had negative 2x squared plus 100x? So we have this polynomial. What is the degree of the polynomial? Well, the degree of the polynomial is its highest exponent. Remember, there's really a 1 there when x is all by itself. So the degree of the polynomial is 2. What are the individual terms of the polynomial? Well, the individual terms are negative 2x squared and 100x. There's 2 individual terms. What are the coefficients? The coefficients are the numbers in front of the x. So the coefficients would be negative 2 and 100. Is this a monomial, binomial, or trinomial? Well, you have 2 individual terms here. Since you have 2 individual terms, this would be a binomial, because bi means 2. Take a look at the middle one. X squared plus 4x plus 3. What is the degree of the polynomial? Again, the degree is your highest exponent, so that would be a 2. What are the terms? Well, we have 3 individual terms. We have x squared, we have 4x, and we have 3. What are the coefficients? Well, coefficients are the numbers in front of the x. So we have a 1 in front of that x squared, we have a 4 in front of the x, and we have a 3 all by itself. Is this a monomial, binomial, or trinomial? This is a trinomial. Why is it a trinomial? Because we have 3 individual terms. Take a look at this third one. What is the degree of this polynomial? The degree of this polynomial is your highest exponent, so this would be a 3. What are the individual terms? The individual terms would be a 4m cubed, a negative 2m squared, and a 5. There's 3 individual terms there. What are the coefficients of those terms? Well, it's the number in front of the x, and in this case, it happens to be an m. All right, so we would have a 4, we would have a negative 2, and we would have a 5. Is this a monomial, binomial, or trinomial? There are 3 individual terms here, so this would be a trinomial. How would the 3 be a coefficient if it isn't in front of an x? It's just the plain number, all right? Somebody asked how this one would be a coefficient. It's just the plain number. Just plain numbers are also coefficients, all right? Just plain numbers are also coefficients. Take a look at these, all right? These are just some more examples of some monomials, some binomials, and some trinomials. Remember, mono means 1. Notice that there's only 1 term in each of these, all right? Notice that there's only 1 term in each of those. All of those are examples of monomials. And this is to degree number 1 because the p is to the first power. This is to degree 0 because there's no x there, there's no letter there. This is degree 3 because it's the third power. And this is degree 0 because there's no x there or anything. These are all binomials in the middle because there are 2 terms. All right, notice there's 2 terms, 2 terms, 2 terms, 2 terms, 2 terms. The degree of this binomial would be 2 because that's your highest exponent. The degree of this one would be a 1. This is really h to the first power. This degree would be 1 because that's really s to the first power. This is degree 3 because this j is to the third power. This is degree 2 because it's to the second power. Then we have trinomials. Trinomials, there's 3 terms. All right, notice how you have 3 individual terms here. What would be the degree of the polynomial? It would be their highest exponent, so it would be the 3, it would be the 2, and it would be the 2. So those are more examples of monomials, binomials, trinomials. On your Regents exam, they love to give you a polynomial. Remember, polynomial is just the overall generic name of all of these. All of these are polynomials. And then they say, is the following polynomial a monomial, binomial, trinomial, or none? Well, none or not a polynomial. What makes something not a polynomial? What makes something not a polynomial is if the exponent is negative, if your exponent is a fraction, if you're taking the square root of a letter, or if you're dividing by a letter. All right. All four of these things make it not a polynomial. All four of these things, 4 divided by x, you can't have an x in the denominator. You can't divide by x. If you divide by x, it is not a polynomial. If you take the square root of a letter, anytime that you take the square root of a letter, it is not a polynomial. You can't have a negative exponent. Anytime that you have a negative exponent, it is not a polynomial. And anytime that you have a fraction as an exponent, it is not a polynomial. So these are all examples of not polynomials. You might think that it's a monomial, but it's not, because there's only one thing there, but it's not. All right. These are all examples of not a polynomial. Divide by x, square root of x, a negative exponent, or a fraction as an exponent. So that's why on the Regents exam, they love to give you a polynomial. They'll say, is it a monomial, binomial, trinomial, or not a polynomial? All right. These are all examples of nots. It's just sort of something that you have to memorize. All right. Now, what are we going to be doing with these? We are going to be adding and subtracting them today. Later on in the chapter, we're going to be multiplying them. You're going to be multiplying binomials times trinomials. You're going to be factoring polynomials. You're going to be doing all sorts of stuff with them. Today, what we're doing is we are adding and subtracting. Now, you can only add together like terms. So you can only add together x squareds with x squareds. You can only add together x's with x's. You can only add together plain numbers with plain numbers. If we had something to the 5th power, you could only add that together with something from the 5th power. You had something to the 10th power, you can only add it together with something from the 10th power. Anytime that we have a subtraction question, you're going to change it to an addition question. You're going to do that hopefully in like maybe 5th or 6th or maybe 7th grade. You learned how to subtract with negative numbers by changing it to an addition problem. You probably learned either the saying stay, switch, switch, keep, change, change, or add the opposite. Where did you learn how to do that? You learned it in questions that might have looked like this, for example, -4 minus 3. You're keeping this one the same. You're changing your minus sign to a plus sign, and you're changing your positive to a negative. So you learned probably one of these 3 sayings: stay, switch, switch, keep, change, change, or add the opposite. You made a subtracting question. Remember, this was really our question, -4 minus 3. You learned one of those sayings to make it into an addition question. That's what we're going to do today. Then you have to put your final answer. You always want to put your final answer in standard form. Remember, standard form is your highest exponent to your lowest exponent in that order. So it says determine the sum. Sum means to add, or difference. Difference means to subtract of each. So take a look at A. Now, first of all, when you have an x squared all by itself, please remember that there is really a 1 in front of that. All right, that becomes very important today. So you're doing this trinomial plus this binomial. How I would suggest that you do it, I think it is very confusing if you leave it going side to side. I would change a horizontal looking problem into a vertical problem. All right, line up your x squareds under your x squareds, line up your x's underneath your x's, line up your plain numbers underneath your plain numbers. That will help you keep things nice and neat and in order. So we have 1x squared minus 2x minus 3 plus 2x plus 1. So what I'm going to do is I'm going to put a plus sign here. I'm going to draw my sort of equal sign, all right, as my line. I'm going to line up my 2x underneath this 2x. I'm going to line up my 1, my plus 1, underneath my 3. So I lined up my x's underneath my x's, my plain numbers underneath my plain numbers. And now I'm just going to add going down. So I didn't have to do stay, switch, switch, keep, change, or add the opposite, because this was originally an adding question already. All right. You only have to do that when it's a subtracting question. So this is an adding question. I'm just going to straight up add going down. 1x squared plus nothing is 1x squared. -2. Now this is really a +2 here. All right. -2 plus +2. Now that's really 0. That's really 0x. And then -3 plus 1 is -2. But when I write it, I'm going to write -2. Now, if this was a multiple choice question on your Regents exam, you would not see this listed as an answer. This isn't the most mature way to write it. Is it technically correct? Yes. But is it the most mature way to write it? No. Normally, when there's just an x squared, when there's a 1 in front of it, normally you don't see the 1 in front of it. If it is a plus 0x or plus 0 of anything, normally we don't put it at all. And then we just have our -2. So if this was a Regents exam multiple choice question, the most mature answer that you would see there is x squared minus 2. Take a look at the adding question that's down below it. All right, take a look at C. I'm going to skip those for a second. Go to this other adding question. Again, what we want to do is we want to put our plus sign outside and draw our equal sign. So now we want to line them up. We want to put our x squareds underneath our x squareds. Well, in this one, we don't have an x squared. So this is sort of the, without making a mess of this problem, this is sort of the x cubed column. This is sort of the x column right here. I'm going to squeeze in the x squared column right here. And I'm going to put this 7x squared right here. Now, why am I putting it there? I'm putting it there because I want to put in the order in standard form, so I don't have to rearrange things at the end. So I have my cubes, I have my squareds, I have my just plain x's, and then my just plain numbers. So I'm putting things in standard form already. I'm going to put my -8x underneath my 5x, and then I'm going to put my +9 underneath my -2. So I'm sort of lining things up to try and keep them nice and neat. All right. Let me just touch this up here. So when I go to do my answer, I want to add going straight down. 4x to the third plus nothing is 4x to the third. I have nothing plus 7x squared. 5x plus -8x is -3x. When I write it, I'm going to write -3x. Then I have -2 plus 9. -2 plus 9 is a +7. So I'm going to write +7. That is my final answer. And notice that my answer is in standard form already. I have my biggest exponent first, 3, 2, 1, 0. All right. So I have my answer in standard form. Take a look at our subtracting questions now. Now, with our subtracting questions, here's what you need to do. I would change it to an adding question right away at the beginning. So to do that, you're going to change your minus sign to a plus sign. And then you're going to change all of the signs in this second thing. All right. In the second polynomial. So this 2 changes to a -2. This +5 changes to a -5. And this -6 changes to a +6. So we're keep, change, change. Stay, switch, switch. Add the opposite. So you take the opposite of all of those terms. So now we have an adding question. So I'm going to put my plus sign here, and I'm going to draw my line. I want to line up my x squareds underneath my x squared. So I have a -2x squared here. I have a -5x here. And I have a +6 here. So again, you want to line up the x squareds underneath the x squareds, the x's underneath the x's, the plane numbers underneath the plane numbers. And now I would just want to add going down. Well, 2x squared plus negative 2x squared, that would be 0x squared. Am I going to write 0x squared? No, that just totally cancels out. 3x plus negative 5x is negative 2x. Negative 4 plus 6. Negative 4 plus 6 is positive 2. So I'm going to write plus 2. This would be my answer. Take a look at D. In D, notice that I have a subtracting question. So I want to change my minus sign to a plus sign. I want to change all the signs of the other terms. So this 8 is going to be a negative 8. This minus 2x cubed is going to be plus 2x cubed. This plus 1x is going to be a minus 1x. So now I want to line them up. Now, this one is going to be sort of a pain in the butt. All right. We want to line up our x to the fourths with our x to the fourths. So I'm going to put my negative 8x to the fourth here underneath my 9x to the fourth. I'm going to put my plus 2x to the third. Notice that I don't have a, just like in letter C, I don't have a space for the x cubes. So I'm going to make its own little column here of 2x cubed. And then minus 1x. Again, I don't have a space for it. So I'm going to create my own one here. All right, because I don't want to accidentally add that to the 5. You can't add together a plain number and an x. You have to have the same exponent in order to add going down. 9x to the fourth plus negative 8x to the fourth is 1x to the fourth. Now, do you have to write the 1? No, you could just write it as x to the fourth. Nothing plus 2x to the third is 2x to the third. Nothing plus negative 1x is negative 1x. 5 plus nothing is 5. So this would be our final answer. And notice that that is in standard form already. We have our x to the fourth first, then our cubed, then r to the first power, then r to the 0 power. So let's take a look at another one of these. All right. I want you to try this one on your own, please. All right. Try this one, write it down. Try this one on your own, please. This is an adding question. So I'm going to put a plus sign out here and I'm going to draw my line. I need to put my 5x underneath the 4x because I need to line up my x's and my x's. I'm going to put my minus 2 underneath the minus 5. So I want to add going straight down. 5x squared plus nothing is 5x squared. 4x plus 5x is 9x. Negative 5 plus negative 2 is negative 7. However, when I write it, I'm going to write minus 7. So 5x squared plus 9x minus 7, it's in standard form already with our biggest exponent coming first. Try this one, please. We are going to change our minus sign to a plus sign, and we're going to change all the signs in that second polynomial. So that's going to be a -8 plus 3 minus 7. We want to put our plus sign and draw our line. You want to line up your x to the third with our x to the third. So -8x to the third goes underneath -2x to the third. We have plus 3x squared. Do we have a column for that? No. All right, so we sort of got to make our own column here for a 3x to the third, or 3x squared. Then we have a -7 at the end, which goes with that -7. So we're adding going down. 5x to the fourth plus nothing is 5x to the fourth. -2x to the third plus -8x to the third is -10x to the third. Nothing plus 3x squared is 3x squared. That's a +3, so that's why I'm putting +3. Then at the end, we have -7 plus -7. -7 plus -7 is -14. Notice that this puts it into standard form right away, which is what you want. One last one. Try this one, please. So again, we want to change our minus sign to a plus sign, change all the signs in the second polynomial. So now we want to put our plus sign, draw our line. -5x cubed needs to go underneath the x cubed. Oh crap, we don't have any x cubes. But remember, 3 in standard form has to come before 2. So I'm going to make our own column out here at the very beginning with our -5x cubed, because that goes before the x squared. We have a -2x squared. That's going to go underneath the 10x squared. And we have a +6. I need to put that +6 underneath the +5. Do I have any x's, just plain x's? No. So I'm just going to leave that part blank. Again, you want to add things going straight down, all right, because we have our columns here, all right? So nothing plus -5x cubed is -5x cubed. 10x squared plus -2x squared is 8x squared. -4x plus nothing is -4x. 5 plus 6 is 11. So this would be our answer. Again, change when it's a minus, when it's a subtracting question, change the minus to a plus, change all those signs in the second row.